Hey everybody, good job hanging in there. This is a long section, so we just have a couple more problems to look at. So what we're going to do is we want to see how long does it take for an investment to double in value if it is invested 8% compounded monthly. And so in this case, we're not sure how much money we're going to put down. So let's just say that P is 100 right now. And the question's asking how long is going to take for that to double if it's invested at 8% compounded monthly. And so what that's telling us in this scenario is that A would end up being 200. Right? And so you can have situations where it's tripling. In section 4.8, we're going to be looking at half-life, which means if you start with 100, how long does it take to get to half that? So instead of it being 200, this would be 50. So for now, let's just go back to our problem and see how to approach this. We see that it's compounded monthly, so we know we're using the formula A equals P times 1 plus R over N to the N times T. Let's list our parameters. And from the get, we want to know how long, so we don't know what T is. We also don't know what A is, but we know A is based off of that. So I'm going to call P just P. So for instance, if it is that 100, then the amount would be double that. So we're just going to say it's 2P. R is 8%, so let's write that as a decimal, and N is 12 because it's compounded monthly. Let's plug all this information in, so we'll have 2P equals P times 1 plus 0.08 over 12 to the 12 times T. And we see that the equation that we're left with is an exponential equation because the variable is in the exponent. And if you recall, the way that we solve exponential equations is we want to isolate the exponential part. My base is 1 plus 0.08 divided by 12, so I need to get this part by itself. So to do that, I just need to divide both sides by P. I'll end up with 2 equals 1 plus 0.08 divided by 12 to the 12T. And in order to bring down that T, you can log or ln both sides. So I'm going to choose to natural log both sides. This would be ln 2 equals ln 1 plus 0.08 divided by 12 to the 12T. The 12T is going to come down as a factor, and I need to finish solving for T. So I'll have ln 2 equals 12T times ln of 1 plus 0.08 divided by 12. To solve for T, I need to divide both sides by 12 times natural log of the stuff. So I'll be left with T equals ln 2 divided by 12 times ln of 1 plus 0.08 divided by 12. And when you punch this into the calculator, make sure, and again I'll just type in ln 2, make sure you close your parentheses up top, and the key to getting the correct answer on this is that after you hit the divided by bar, insert some other parentheses to ensure that this factor in the denominator is in the denominator. If you do not include the parentheses, your calculator is going to compute natural log of 2 divided by 12 and then times the ln of this. So in order to get that factor in the denominator, you need to include the extra parentheses. And after you compute this, you're going to find that t is approximately 8.69 years. Alright, so for part B, it is how long does it take for an investment to double if the interest is compounded continuously? So compounded continuously means we're using A equals PE to the RT. And again, when we list our parameters, we want to find the time. The R we're assuming it's the same R. Sorry, not a clear problem. Assume R is still 8%. So then your R over here, you want to change to a decimal. We're trying to double, and so this P will just keep as P, and A is 2P. Plugging everything into this formula, we have 2P equals PE to the 0.08 T. We're going to divide both sides by P to isolate the exponential. So I'll end up with 2 equals e to the 0.08 T. I'll natural log both sides. The 0.08 will come down as a factor, and natural log of e is 1. And so, my answer is going to be t equals... I'm getting some delay. So it'll be t equals natural log 2. Oh, shucks. Alright, so we're going to end up getting t equals ln 2 divided by 0.08. Plugging this into our calculator, we'll get 8.66 years. Not a big change in years, but that's how we're going to approach the problem. And you should expect that this would be less time because it is compounded continuously. When we are doing these problems, notice at these steps, at this one and this one, you had the 2 there. It's not uncommon. That's something that we should expect. And so it kind of, you know you're doing something right if your problem is asking to double and you're seeing a 2 at the amount side. Alright, so I hope you found this helpful, and I'll see you in the next video.